Welcome to TOCS. This is a TOCS on Computing Systems lecture series that occurs at CMU as our centerpiece of our community outreach to the intellectual community. It's a place where we have speakers from all over Silicon Valley and beyond that come from all of the best academic and industrial startups and so on to give a talk that gets recorded and kept. It happens every week during the semesters, if we are lucky. And we're lucky when we have interesting and exciting people to share with you. If you have questions during the talk, we will pass around this microphone. It's a way of knowing who has control over the conversation. And I'm sorry if it's hard to get to. It shouldn't be that hard. Just raise your hand. I'll run around and try to help. And anyway, today one of our faculty has brought a friend of his, Minted, and I'd like Colin, please introduce.
Hi everybody, I'm Colin Jackson. For those of you who don't know me, I'm faculty here at Carnegie Mellon Silicon Valley. I do research on web applications, security and performance, as well as browser security. And we're very lucky today to have Alex Nobert, who is the Director of Operations at Minted, Technical Operations at Minted. So they are a crowdsourced design website, and I'm sure he'll tell you about it. And previously, he was at Vox Media, which runs the Verge, as well as Shopify, which powers tens of thousands of online storefronts with hundreds of millions of page views. So we're very excited to have him here today to talk about scaling web applications.
Thanks everyone for coming out. First, I just want to get this out of the way. I've been mistaken for a student a few times. I've actually been doing this for 15 or 16 years now. While it might not look like it, I've seen terrible, terrible things on the internet, and I'm an empty shell of a man inside as a result. So yeah, I'm here to talk about web operations scaling, the trials and tribulations of that, and a little bit of background about what web operations entails. First, a little bit of background about myself. I started in earnest at Shopify, and as Colin said, it is basically hosted e-commerce, hosting 40,000 stores. There are a wide array of stores. There are very big names. Examples of names you've heard of: Foo Fighters, Beastie Boys, Tesla. Those are big shops. The vast majority of them are medium to small. But that having been said, 40,000 stores is a lot, and being able to scale for that is a challenge. And bigger challenges are scaling for holiday shopping season. So e-commerce is very seasonal. Black Friday is obviously a huge one. So that represented, just like on Black Friday, is double or way over double the amount of traffic out of a normal day. And then on top of that, flash sales, TV appearances. We've had customers on Oprah, on The Daily Show, and those are like 10 or 15 times normal traffic. So being able to scale for spikes was always a big thing. And unfortunately, Shopify was frequently targeted by denial of service attacks, which is a whole other set of challenges. Normally, you want to be able to service the traffic. With DDoS attacks, you want to divert the traffic. So we had customers who were attacked on a fairly frequent basis. If you're familiar with Encyclopedia Dramatica, they were frequent targets, and just other small shops for seemingly no apparent reason were just getting attacked on a regular basis. So we had to manage that. After Shopify, I went to Vox Media, and Vox Media had a whole other set of scaling challenges. The big Vox Media site is The Verge. I hope you all go to it for your tech news. But the big scaling issue at The Verge was being able to handle traffic from Apple product launches. It's a whole different pattern of traffic than with e-commerce, and it has mostly the same types of technical challenges, but they're coming at different times and in different, maybe not as immediate spikes. As like a flash sale, you get all your traffic within like minutes, like 5 minutes, whereas with an Apple product launch, you would have hundreds of thousands of concurrent connections for the whole course of the event. And there was also covering trade shows. E3 was a big one. SB Nation is a sports site, so there was coverage of Super Bowl, UFC, events like that. And of course, Apple product launches were horrible. Today, I am at Minted. And so Minted, as Colin mentioned again, is basically e-commerce. So again, very extreme seasonal spikes, more so than I've ever seen before at Shopify. I learned the day I started that there's such thing as the engagement season, which has a crazy spike. I had no idea about the engagement season, so I said it twice. I'm quite excited about the fact that there's an engagement season. So anyway, yeah, today I am going to talk about, as I said, operations. The question is, what is operations? I'll start by saying what was operations. When I started 15 years ago, I was a system administrator, not tech operations wasn't really a term that was used. So what my role was as a system administrator was we would get a server. I would plug it in. I would install the operating system, Linux, on it, put Apache web server on it, would maybe put a database on it, plug in a network cable, and then I would get out of the way and the developers would have their way with it, and I would just do whatever. Right, so the only time I would ever come back to the server is if something was breaking, hard drive was failing, hard drive was filling up, someone has installed Counter-Strike on it, something like that. So things began to change as web applications came to the forefront. They became more popular. So obviously this was during the bubble in the late 90s, early 2000s. Web applications became very, very popular. And for the first time, they were hitting physical system limitations. And at that point, the developers who maybe didn't know that much about it would start coming to system administrators and say, help, we need to figure out how to scale for this new traffic. So that is when sysadmins became part of the greater web application development cycle. So, right, so today the system administrator is in the startup world not something that really exists anymore. A lot of startups can't afford to hire someone who is purely and just a system administrator who plugs computers in and leaves. And likewise, you can't have, until you get to a certain scale, of course, it's harder to get someone who is just a network administrator or someone who is just a database administrator. So what has happened is that those have merged into one role, and that role is operations engineer. The operations engineer at a startup is responsible for systems, networks, database, and a myriad of other things. Right. So as I said, operations engineers have to know all of those system network things. But in addition to that, because they are tightly ingrained as part of the team that is working on the application and scaling the application is a big thing, of course. Operations engineers also have to know about everything that lives above those components. So the application itself, the code base, they have to know that, and all of the stack. So if you have a caching layer, we have to know that. If you have a queuing system is another thing. Basically, every component that is living on a server somewhere, operations has to know not only about it, but how to use it and how it interacts with other components and its profile. Because one of the big things in scaling and uptime is just recognizing when something is not working right, because that will lead you to a root cause and then being able to fix it. This, by the way, has never, ever happened to me. Great, so today is, scaling. Today is launch day, let's say. We have a startup. The startup sells intelligent pizzas online. So the startup has developers, really good developers. It's got a fantastic design. You have a great viral marketing campaign lined up. And right, it is launch day. This is actually version 2. So we are deploying some new features. One of those features is there's a live chat. This live chat, you can talk with your pizza before ordering it. And there is a photo upload service. You can take pictures of you with your pizza when you get it, and there's like a whole social network about it. I guess you can like tweet about eating your pizza after. So launch is coming up. The developers have committed all their code. It's super well tested. The lead developer is pushed to the servers, and a bunch of things happen. Probably magic, and then features are live. And because a celebrity has tweeted about your startup, great, intelligent pizzas, you can chat with them online. Everyone is very excited. You have a torrent of new traffic. What happens next? What happens next depends on whether or not your database can handle all of the new write traffic that is coming in from the live chat. Can it process all of the pictures that people are uploading? Can the app servers handle all of the connections concurrently from the live chat and from the social network? So that is the domain of ops. While the developers were creating all these features and iterating and testing them, an ops team would be paying attention to that and would be testing and provisioning new hardware. Perhaps the database they have determined is too slow, so they've upgraded it. Basically, ops team in conjunction with the developers have been anticipating what is required for to be able to handle this new scale. And without the ops team, obviously, there's fire in Kevin Sorbo. So, how do you scale? The path to scaling, put simply, is simply identifying and eliminating bottlenecks. This seems incredibly obvious, and anyone can do it. So let's do this. Step 1: identify your bottleneck. Pretty simple again. The trick is simply when you're looking for something is knowing what it is you're looking for and knowing where to look for it. So in the case of scaling, you just want to know what are your finite resources and what are your application's interactions with them. So we're back here. This is this is usually where you will notice the first notice a large impact of having an ops team. Without an ops team, and especially in a startup environment, it's very fast-paced. Rapid iteration is important. Developers tend to focus on adding features, adding functionality. Just more features. And that's good. That's great. So the role of the ops team is to understand the impact of that additional functionality and those features on the greater system. And of course, at a startup, it's possible that it has happened that some developers have committed horrible atrocities to your servers. It works fine on my laptop, but then we put it in production, and it turns out that it's doing 150 queries for every request, and then everything falls over. Again, this is the role of the ops team, not just to find it, but also to educate the developers in this. And that's fine. Again, developers going to develop. Ops have their back. So what are the components of your applications? Again, you have to understand what all the components are, what the resources are that they're consuming, and how they talk to each other. This is, again, super simplified. My dog helped me with this. application is simply your app code and maybe the stack that it's running on. You have a web server, an application server, some caching. Data stores are your database. It might, so in a startup, it's typically something like MySQL. You might have some other more clever ones. And then they're all talking to or run on servers. And those servers and network devices all have physical limitations. And these are where your bottlenecks will start to show up. Servers have, server is a computer. A computer has obviously a processor, has physical memory, and they have disks. And those are all going to be the location of your bottlenecks. CPU have finite amount of processing power. Obviously, there's a limited amount of RAM in every computer. And disks are slow, and everything uses them, and they have, again, finite capacity. One level up from that is the operating system. The operating system also has imposes limits, and some of them are things that you can control, and some of them are just finite limits that are beyond your capability of changing. So examples of that, again, shared memory. So coming from the Linux world, there are limits on a process's maximum amount of memory can allocate, number of files it can open, and it seems pretty simple. It seems like limits that you're not going to hit, but so for every connection that you have to a web application, the socket will count as one. You will open 2 or 3 log files maybe. All of the shared libraries that the web server has to open to work, and then your web application is probably dozens of files, and then if it has to start writing out temp files, they add up, and so you have a per process limit, and you might have an operating system limit as well. And again, it might work great on your laptop because it's just you, and it might work okay in staging because it's just you and your 25 colleagues, but if you put it in production and you have 25,000 users, then you start to notice bad things happening very quickly. And so the operating system also has literally hundreds of other things. If you have access to Linux, check out proc sys someday for hundreds of very poorly documented switches and knobs. So next, network. The big one, of course, is available bandwidth. This is, in most cases, something that you will only notice if you're being DDoSed, but there are certainly cases where not just bandwidth, but also the speed at which your application is delivered. So if you are serving images and the images are not compressed, or you're serving HTML to mobile devices and those are not compressed, those will impact less so scaling, but definitely perception of being able to handle the scaling or the load. So those are things that you have to watch out for. You have to monitor those, and again, that is a function of the operations team. And then you have firewalls and load balancers, and there are other things, switches, and they all have limits as well. Particularly with a firewall or a load balancer, they're really, truly just computers, and they have processors, and they have memory, and in some cases they have disk, and they will also have operating systems that have the same limitations. So you'll run into cases where you have more connections than your firewall is actually able to handle, or you'll be pushing more bandwidth than your load balancer is rated to handle. And that is even not just under denial of service attacks. You have to make sure that you have provisioned network hardware that can handle your traffic. So starting out small, you might be able to do so on like a Linksys router, but when Oprah tweets about it, that's not gonna fly anymore. So in addition to those common and very integral parts of your systems, there are dozens of other things that you have to consider, and they all have limitations too. Your web server has connection limits. It consumes memory. You might have rules in it for filtering traffic or sending traffic to different places. Those will take up resources, so you have to understand those things. Maybe you have cloud storage. Cloud storage has high latency, so you have to understand how much time it takes to send or get back files from that. Full text search is a common one, and it is a persistent thorn in most companies' sides. How to search quickly. So you will have a search server, and it is super disk intensive, and you want to cache as much as you can. So you have to have tons of memory, and searching and indexing is a very taxing operation. So those are consuming CPU resources. So you have to keep an eye on those things. That's all part of the greater application scale. Okay, so we have all this, we're armed with all this information. We have tools, we know what we're looking for, we know where to look for it. Let's find us a bottleneck. So this is the profile of a healthy app. Healthy-ish, because it's a little slow, but we'll call it healthy. So let us launch our new social network and our new live chat and some photo uploading. Oh, so that's bad. This is this orange mountain is time spent in the database, and that is about 6 seconds on average. That is quite bad. What's going on? Well, what could be happening? There are, again, we'll go back. The data stores run on servers, and the most common problems on a database are, one, disks. So everything is being written to disk, obviously, and if you're talking about an application that writes on every request, let's say, well, you're going to have write contention because disks are really, really slow. Many operations are done in memory. So an example of that is just you are pulling back a huge data set. It has to put it into memory and sort it maybe, or maybe it's doing filtering. That's done in memory. And again, doing it with one client, very easy, times 25,000, very hard. And likewise, processing power. Well, everything that the computer does, the database does, is requires a CPU, and the more you tax it, the slower every single other thing that is happening on that server is going to be. So that's okay. This application happens to be doing a query that is not using a database index. That is a cardinal sin. It is also sorting, it's a giant table, it's sorting all of these in memory. Every single row in the table is sorting, and every request is doing a lot of writes and many, many reads. But we can handle that, we can deal with this. Again, these solutions are blindingly obvious in many cases. You have a query that's not using an index. Well, let's create an index. You have 3 million rows returned, and you're only using a few of them. Well, let's just rewrite the query to not return so many rows, especially if we're not using them. And your disk is not able to handle the writes. Well, use faster disks. So use faster disks. It seems brutish, and it is, but that's okay. Sometimes, especially today, there are so many services, tools that at our disposal. Cloud computing is obviously like a big part of operations now, and it's wonderful. Cloud computing lets you scale like horizontally, almost infinitely, not really, but a lot, and you can distribute your load across all those, and it's a truly wonderful dream. We need more power. Let's just spin up some servers, and that is fantastic. It is a good dream, and it is frequently a good reality too. But there are also cases where that's just not going to work. Maybe it's not going to work because it's not technically possible. Maybe it's not going to work because it's really super expensive to do that. And that is, again, operations is tasked with knowing these things. And sometimes operations is knowing that things are too expensive to be feasible. But sometimes it is, oftentimes it is knowing that it's, whether or not it is technologically the right way to do. So vertical scaling, again, super brutish. It used to be the only way to get things done. And like I said, with the proliferation of things like cloud computing, it's kind of thought of as a little simple, a little caveman-ish, but it's also super effective. And in the case of our database server, the disk is too slow to handle all the writes. Well, maybe that is actually the correct solution. There is such a thing as a database server software that in which you can spread writes across many servers in a cluster. And that is also a wonderful dream, but a lot of that software is going to be not robust enough. Maybe it hasn't been tested well enough. A lot of these things are immature, and it's great that we live in a world now where there are more database options than just MySQL and MSQL and Oracle. So there are tons of great options now, but do you really want to entrust your database? This is like the lifeblood of your application to something that you're not really familiar with and might crash. And if it crashes, might not be support. Answer is probably no. So we have to scale our database to be able to handle all these writes. Great, we have a solution for that. Solid state disks. A lot of times,
Yeah, excuse me, you seem to say that maybe RAID is unreliable as a solution for this?
No, RAID is not unreliable. It's the software more than anything. RAID will only get you so far. You can spread your writes across many disks, but it's not really that scalable because you're not really even getting 100% increase in speed for each disk you're adding, and also for each disk you're adding, you probably want to have mirrored disks as well. So for every disk you add, you actually have to add 2 to get less than 100% increase in write throughput. So it
adds complexity.
Well, it adds complexity, but it adds cost. And in a data center, the biggest problems that you're facing with when hosting is not number of servers. It's actually density and power and heat. Heat dissipation is a huge issue. So the more disks that you are putting into a chassis, the hotter it gets. So you have to be able to cool those. And there's a finite limit to how much you can cool servers. And those disks also are very high power. So power is actually probably the most expensive part of physically hosting. So the answer to that is that your cost per to performance is very, very high, and then you probably have to add multiple servers to be able to handle the equivalent of just adding one. Actually, you definitely have to add multiple servers and tons of disks to achieve write speed and read speed comparable to adding just 2 SSDs. Solid state drives, by the way, you should always use them. Spinning disks are dead. Right, so I was talking about not over-architecting, being okay with the simple solutions. Obviously, you all like to do things that are clever. Developers love clever and ingenious solutions, and that's actually true in ops as well. We like to do things that are really neat that we can talk about and maybe give talks about after. But it's also important to be mindful that sometimes a really clever solution that has a lot of moving parts is not the best way to do it. And it might be that there's not enough time, or that it's quite expensive, or that nobody has the expertise to support those solutions. And it might just be that there's a way, way better solution that sounds kind of so simple that you wonder, why hasn't everyone done this? So my favorite example, and an example that I am proud of and I'm here to brag about right now, at The Verge, we covered, as I said a couple times, Apple product launches. And the way we cover that is by live blogs. Surely you've seen live blog coverage of something like this. So live blogs present a somewhat unique use case in that all of the traffic is going to the same place, and it is concurrent connections because you want the updates to come in live. So The Verge used to use a third-party service, which shall remain nameless, and it couldn't handle the scale of an Apple event. So it happened at one of the larger ones that that service was handling live blogs for many major news outlets and The Verge, and it fell over. It just could not handle the scale, and it was a huge disaster. And then they said they fixed it, and at the next event, the exact same thing happened. Maybe not the same root cause, but they were not able to scale to handle that. So it was decided internally that in 6 weeks, we would develop our own live blog to handle the next Apple event. The developers were understandably super excited about this because A, we were tired of being yelled at, and B, super cool problem to work on, that it's very different from just being able to serve blog pages or something like that. So the developers were pitching all sorts of new tools they wanted to work with that they hadn't worked with before. Some of them they all were quite immature. So Node.js is one that is able to very easily handle and quickly handle a large number of connections. So that was one possibility. People were pushing a plugin for a web server that can handle long HTTP connections for HTTP push effectively. So that solves the how to push live updates, but it also means that the servers have for every user, basically, you have to dedicate at least one connection that is always going to be available. The plan was to put it on Amazon EC2 to leverage cloud computing. So each server basically was able to handle only a finite number of connections. So there are basically memory implications to that, and like open files. So a problem solution is, well, let's just add a ton of servers. Maybe we determine that each server can handle 200 connections, and we have to handle 200,000 users. Well, we can do the math. That's a lot of servers, and there has to be a way for all of those servers to actually get the updates. We can use a key value store called Redis, which supports replication, and each server can have a Redis server on it, and they can just replicate down to 200 nodes. And that might work, but we have 6 weeks, and it's going to take 4 weeks of development. And if we test it and find that it's actually not going to work, we're doomed. We had a planning meeting, and I pitched something that when people first heard it, they said, "You are an idiot. Just please leave us alone." But then they thought about it and they said, "Well, that's actually kind of ingenious. Why does anyone else do it?" So the solution was, let's just put all of our updates into a flat file on a hard drive somewhere. Anyone can scale a server that is only delivering text files. Great. Okay, so then we have an application that is just writing updates. Every time there's an update, we'll rewrite that file. And the client is basically just JavaScript, and it is every 1 or 2 seconds is going to refresh that file. You're not hitting none of the clients are hitting a database. There is no code being executed. It is literally just open a file, and that can be cached. And it turned out that was also far easier to develop. The prototype was done within days, and we proved that we can deliver updates with very low latency. And so this was actually tested by operations. We we prove that we can deliver the updates within 2 seconds for 95% of clients or something like that. So there was a little more logic on the client side of JavaScript if you needed to get, so the file for performance reasons was only the 10 most recent updates. So if you wanted to scroll back, there were other files. Anyway, so that's neither here nor there. The important thing was that we took a very, 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 very dumbed down solution to being able to scale to handle 200,000 live blog users without having to use any servers at all. So yeah, for extra scalability, we put it on Amazon's S3 service, which is just a cloud file hosting service. So we leveraged Amazon scalability to allow our live blog to scale virtually infinitely, basically at Amazon scale. Again, maybe not as exciting for the developers. They did not get to play with their exciting new technologies, but that's what hack days are for. So we served the Apple live blog and many live blogs after that without any problems whatsoever. And it felt good. It felt quite good. In ops, not every problem is going to have such a simple solution, but when you run into one, just run with it. You will feel great after. So what else in operations can go wrong? Well, everything can go wrong. Maybe you have your home page is really slow, but it never changes. So cache it. Put a front-end cache in. There are many software packages that will let you do it. Varnish is a good one that we like to use. Doesn't change. So yeah, cache it. Your new connections sometimes take forever for no discernible reason. Maybe when establishing a connection to your database, there's a 3-second pause for some reason. Well, we've seen that happen. And in our case, it was that every new connection was doing a reverse DNS lookup as part of the host access check. We don't need that because we know who's connecting. Turn it off. My app servers are running out of memory. Well, you need more app servers. What is query cache contention? All you need to know about query cache contention is that it is the worst thing ever and you should never turn it on. And yes, serving images slow, put it on CDN. These are common problems. They are all completely different problems, but they are all things that are within the domain of operations.
Another
yeah.
quick question. So, when I first started learning about operating systems, it just seemed like an endless list of things to remember and do, right?
It is.
And I'm looking at this, and it just seems like, a random long list. Is there any theory in it? Is there any way you can test these things before you run into them? Or is it just like you find someone walking down the street that has, 10,000 things in their mind because they've done it before and that's the only answer?
Two things. And actually the next slide will expound upon this. Experience goes a long way. So it's probably not as much knowing the answers or even the questions, but it is really just knowing how to get what the process is and being able to quickly find what is happening and then find how to fix it. Yeah, sorry, what was the second part of your question?
Is there a theory?
No. So, I mean, the biggest problem is that every application and every set of components talking to each other are slightly different. It's more so with applications. Like, even if you're using the same application framework, Shopify's Rails application is very, very different than Vox Media's Rails application. They do different queries. The data they're using is different. There are different components. Their caching layer is different. Everything is different. It's really, is there a pattern? The pattern is that anything that can go wrong probably is going to go wrong at some point. So test a lot and just try to be on top of changes. I mean, it's a common idiom, like developers never are able to code something right on the first try. I don't know if that's actually true, but it's frequently true. And you just have to make sure that you're paying attention. The biggest thing is just noticing when something is going to go wrong. It's really hard to do anything, especially at the speed that startups like to iterate at. It's hard to catch everything before it hits production. You do your best, but like I said, it's impossible. Um, so the trick is just knowing how to find those problems. So I'm glad you asked that because this actually leads into the next part. You can go a long way in operations by simply checking the logs and following where that takes you. And most things will, if there's something happening, will spit out something in the log. So check the log, find out what it's spitting, and paste it into Google. Google is your best friend, or whatever search engine. I don't actually care when I'm interviewing ops candidates. I care less about what is already in their head. I really care more about the process they go through when they run into a problem, because as you pointed out, there's an infinite number of problems, and it can be in all sorts of areas because operations is handling databases, caching, network, operating system, application problems. It's you can't know, and you certainly can't foresee all of the possible permutations of problems. So being able to quickly diagnose a problem, not just seeing that it's there, but having a pretty good idea of how to get to the root cause, because you don't want to be treating symptoms because then it'll just happen over and over again. You want to get root cause. So if I'm doing an interview and I present someone with a technical test and they go to Google, that's a good sign because that's what I do. And that's what I would expect anyone in ops to do, is if you don't know it already, don't wait around until it comes to you. Go find it. So like you can go, and people do go a long way by simply just pasting into Google or typing in the symptoms into Google. So the question that people frequently ask me is, why on earth would anyone want to do this? And I have a friend who is running a startup of his own, and it's smaller. They don't have an ops team, so he's doing ops himself. And he said something along the lines of, operations is terrible. It's like the best you can expect is like you are 1 minute closer to your next downtime. That was a little dark, and it's to be honest, it's not for everyone. But if you enjoy solving problems, like if you're a person who likes puzzles, there's an infinite number of puzzles in operations. And if you derive any sort of joy out of solving people's problems, and you're okay with maybe only ever high-fiving yourself, man, operations is actually tremendously rewarding. And I high-five myself on a frequent basis. And so the other thing is that when I started system administration, the tools were only ever made by other system administrators, and they weren't very good at coding. Today, we are very, very fortunate that there are a wide array, dozens, well, like 10 really, really awesome tools. So get to know them. They're going to help you find problems. So like the big thing is just knowing how things work so that you can see when they're not working the way they're supposed to. And these types of tools are going to help you. Some of them are log aggregation and graphing, live graphs of what's happening, aggregating errors, just system monitors. There's a lot out there now, and there's a community that's actually working hard at improving lives of people who are doing operations. And again, Google is always your friend. Yeah, that's all I have. Thank you very much for coming. Thank you for staying awake.
Thank you.
Yeah, I hope people I have not scared people from doing operations.
There's two things. We have cookies and drinks out in the hall for people to meet you. But I'm sure that people have interesting questions. And so please, I especially like it when students make a point of asking questions. Anybody?
So how do you get that graph that shows the spikes in usages?
Good question. So that particular graph was from an application called New Relic RPM. And actually, the first time it was shown to me, I said, where has this been all my life? It's relatively recent. It's a hosted service. You basically install an agent in your application, and they provide agents for basically every programming language and framework. And like magic, all of a sudden it is able to show you what your application is doing, like graphs, times. Like the graph is the simplest part of it. It will show you the slowest controllers, like the slowest actions, and then you can drill down. What is that action doing? It will show you all the database queries it's doing. It will show you time it's spent caching. It will show you time spent in garbage collection. It's phenomenal, actually. I wish I said it. I could say that I was getting a commission from plugging it. It's really, really good software. Probably the best thing that operations people have right now. And there are tons of other packages that are similar to it that maybe aren't as focused on showing you what your application is doing. They're showing you what your server is doing. Like server density is something that we use for showing you just like system metrics, overall process use, memory usage, disk usage, and things like that.
Any other questions?
What do you use to manage the network interaction? In the old days, you'd use something like an OpenView or Tivoli or something. You still use that, or there's something new and better?
So most places I've been at actually do use something like OpenView. There hasn't been quite as much development in that area aimed at startups. So it tends to be in startups that there's just not a lot of budget or just push to have a better grasp of a network. It's very ad hoc. But having said that, there's a software, a hosted service called Boundary, which is a lot like New Relic for your networks. And it's actually again, one of the greatest things I've ever seen. It is really like as New Relic was for application performance, Boundary is for network monitoring. It'll really show you interactions between your servers at the network level, and it is like invaluable for tracking down network problems, network bottlenecks. I'm glad you asked that because I should really add Boundary to this presentation. Thank you.
There's a question online from Kaushik Gopal. How do the ops teams simulate the testing for a day, for say a launch day event, before the actual launch day?
Very good question. There are tools out there. There are actually hosted services out there which can do the testing for you, and it just depends on what your application is, how complex of a test case that you generate. So at the very simplest case, if you just need pure connections hitting one URL, you can do it yourself using like Apache Bench or Siege. Those are just like command line tools. But if you need something that is simulating an actual browsing experience, maybe using like full JavaScript rendering or just going through the motions of a full viewing experience, like for e-commerce, actually adding something to your cart and then checking out, then there are great hosted services. BrowserMob is the only one I can think of off the top of my head, and I think Blaze.io was one that was bought or something. So the answer is it really depends on how complex of a use case you need. But check out Siege. That's at its simplest case. You can even script some interaction in it. And someone made a wrapper for Siege called MicroArmy, which basically will launch a bunch of EC2 micro instances, each with its own Siege. So you can kind of horizontally scale your own, like roll your own horizontally scaled load testing.
Another question? So a million years ago, I was part of a team that evaluated a workbench, a web workbench for doing administration. It was kind of this integrated workbench, and it was I don't see anything like this. I don't see anybody using anything that's integrated or has any, you know, from a UX point of view, you know where to look for those graphs, and you know where to look to change the network connectivity all in one integrated thing. Is that, am I wrong? I mean, could have you shown us 10 such tools and
There,
nobody
I
uses
mean,
them, or what?
there are just too many possibilities now. Something that is able to monitor every possible, like even just at the database level, you know, there are 20 different database servers. Excuse me, and applications themselves, they could be written in, you know, 20 different languages, and each of those languages has a few different frameworks, and some of those, all of those frameworks have libraries for multiple libraries for each type of database server. There's a lot of possibilities, and it's hard now, I think more than ever, to be able to handle every possible thing. And I mean, it's like a kind of a microcosm of operations. How do you make a dashboard or an application to monitor everything? You can't really. The strategy that people are doing now is just making dashboards that are modular, and then people build plugins for them. And there are definitely dashboards like that can handle. I was looking at one today. I wish I remember the name. Basically, Scout, actually, Scout. It is basically a monitoring framework. It's hosted, and people have contributed plugins for different database servers and for different like parts of their application. There's a Rails plugin. So such a thing exists. They're expensive because they're quite rare, as you point out. But the other thing is that it's not really a thing that businesses care about. So I mean, system metrics are important, but I think what people really are more interested in is what the key metrics are for business health. And like at an e-commerce company, system metrics are important, but you're more interested in like how and revenue. If you notice that checkouts have gone down, then that's a big indication there's a problem, more so than you know, oh, some particular service isn't working right now. Revenue is like, or checkouts, or on at Vox on The Verge, comment rate or post rate. Those are really key metrics of the business, and people are more interested in business dashboards now, and those are unique to the business. So there's always at least a little bit of custom engineering that has to go into it. So I mean, there are again, you can host your own kind of metric systems, but then you have to write your own plugins to plug the data in.
So you're saying the overhead is often not worth it. Maybe they don't have enough coverage for the whole problem.
Right. So I mean, it's hard for a company to make an application and then sell that application as something that can cover everything.
Well, yeah. Whoa. Last question.
That slide you show about, you know, what else could go wrong? Right?
Yeah.
You had half a dozen problems and solutions, things to try. And I guess I'm wondering, is anybody, you know, it seemed like there's a start there for forming some kind of general model of, you know, for these categories of problems, think about these categories of solutions. And, you know, if there were, you know, I mean, one question is maybe a question for the room, is anybody thinking about, you know, how to model this kind of like troubleshooting mentality? And then on the other hand, or is there like some kind of crowdsource, you know, resource that I had this problem and I solved it in this way, that, you know, less experienced people could go and take advantage of your experience, for example?
Okay, so the first part of the question is probably that you would spend more time trying to wade through this giant file or like table of contents than it would be to like go to Google. And the second part of the question is Google, but more to the point, I think there's a type of site like a QA site, kind of like Reddit, basically. You can go and ask a question, and there are specific to there's one that's specific to programming, and there's one that's specific to system administration or operations. So for the ops world, if you're familiar with Stack Overflow for programmers, there's actually one called Server Fault for operations, where you can go and ask a question. You can paste your error message. You can describe your symptoms, and there are a host of experts who will come in and help you. And the other thing is that it's well indexed. It has tags. So if you're seeing something is weird with MySQL, you can type MySQL in, and there's a category index, and you can search within it. So yeah, the answer to that is yes, there is something, and it's actually pretty good. Assuming you have some time to like dig through it or wait for answers.